Hey guys, we're looking at Module 4, Homework B, Tab 3, Part 2, and this is the electric potential of the inner sphere. So we need to calculate the electric potential of V2. So let's go ahead and first start looking at the electric potential due to capital M1. So I'm gonna just write capital M1. So the potential at the radius R22, the outer surface of capital M2, due to M1 is going to be V1. We're going to denote that R22 is equal to capital or lowercase k times Q1 all divided by R2 to 2. And the potential inside of capital M2 at R sub 2, 1 due to M1 is also going to be V1 of R sub 2, 1 is equal to lowercase k times Q1 all divided by R2, 1. Since capital M1 is a point charge for the distances greater than R1, the potential inside of M2 due to M1 is going to be V1 inside is going to be equal to lowercase k times Q1 all divided by R2 to 2. So now let's go ahead and look at the electric potential due to M2. So the potential at the radius R sub 2 due to M2 is going to be V2 out. I'm going to go ahead and do out is equal to K times capital Q2 all divided by R sub 2. And the potential inside of M2 at R21 is going to be V2 inner is going to, that does not look like inner is equal to lowercase k times Q2 all over R21. And the potential on the inner surface of M2 at R21 is going to be capital V2, and this is going to be at R21 is equal to, this is awkward to write in the very corner, sorry about that, is equal to k times Q2 all over R21. I'm gonna fix up these 2's. It's very weird writing from the very corner. So now let's take a look at the electric potential due to M3. So the potential at radius R22 due to M3 is going to be V3 out is equal to lowercase k times Q3 all divided by R32. And the potential at radius R21 inside of M2 due to M3 is going to be V sub 3 R21 is equal to lowercase k times Q3 all over R31. And to find the potential at the inner surface of M2, we need to integrate the potential due to M3 from R31 to R21. So we're going to have V3 inside is equal to K times Q3 all divided by R31. So now let's take a look at the electric potential on M2 at R21. So to calculate the total potential at the inner surface of M2, we need to sub all the potentials due to each cell. So I'm going to there are some parts I'm going to just go ahead and rewrite. So the potential due to M1 is going to be V1 R21 is equal to K times Q1 all divided by R21. And the potential due to M2, since the shell M2 itself has a charge of Q2, its potential contribution at the inner surface of lowercase R21 is going to be, is going to be V2 R21 is equal to K times Q2 all over R21. And then we have the potential at M3. We need to find the potential due to M3, which to find the potential at the potential due to M3. To find the potential at R21 due to M3, we have V3 inside is equal to K times Q3 all divided by R31. And to combine these, the total potential at the inner surface of M2, which is radius 2, 1, is going to be V2 should be capital V2, by the way. All of these should be capital V's, by the way, is equal to K times Q1 all over R21 plus k times q2 all over r21 plus k times q3 all over r31. Since we need the correct expression with the difference in potential inside M2 between R22 and R31, we need to go ahead and just rewrite this just a little bit to be V2. I don't know if the system will take this answer. I didn't check, but this is just what the system took for me. K, and then this should be parentheses, Q1 plus Q sub 2, all divided by R22, minus K, and then in parentheses, Q1 plus Q2, all divided by R31, plus, we should have K times Q1 plus Q2 plus Q3, that's not a very good 3, all divided by R32. And this was the answer I believe was correct in Snape physics, and I hope this helped.